Yes, good afternoon all. May, am I audible? Hello,
Yes,
Okay,
sir.
sir. Yes, sir.
am I audible?
Yes, sir.
Okay, wait for 2 minutes. Some more people need to add. Only few people are there. Okay, wait for
Okay,
five
sir.
minutes. We'll start. Okay, right. Is my screen is visible to you? I have shared a screen to you.
Yes, sir. Visible, sir.
Yes, sir.
One
Visible,
note.
sir.
Do you recognize my pen movement?
Yes,
Yes,
sir.
sir.
Okay, right. Thank you. Just wait for 2 minutes. Yes, am I audible? Right. Let's start the lesson. I think this is the second. Have you received your books? Have you received? No reply from you. Am I audible? Hello. Am I audible?
Yes, sir, it's clear.
Yes, yes. Now I am going to start today pericyclic reactions. I think some first block is pending. Later we will cover it. Okay, freshly I am starting with a new block, that is pericyclic reactions. Till now we have observed so many reactions in the organic chemistry or in the chemistry. We see that some various kinds of reactions like addition reactions. Where the addition reaction participating, where the unsaturated is there, are unsaturated double bonds, unsaturated double
Sir,
bonds, or
voice
means
are
wherever
not
the
properly.
unsaturation is there.
Can't hearing. Hello.
My voice is not clear.
Not sir. Properly.
Now it is okay.
Yes.
Is it
Okay.
okay now?
Okay, sir. Continue.
Now it is okay or not? Or
Okay, sir.
otherwise I will identify other routes. Just a minute. We will check it that. Just a minute. I will arrange the other perfect route. Yes, my voice is clear now. I hope my voice is clear now. Thank you. Now, if you see that in organic chemistry we have seen various kinds of reactions, in which first one is addition reaction. Where the addition reactions takes place generally, if a molecule is having unsaturation, that kind of molecules undergoing addition reaction to produce saturated molecule, like double bond, triple bond, or carbonyl, or other unsaturated groups containing molecules are undergoing addition reaction. Very familiar reactions. And next, substitution reactions. Substitution reactions. Substitution reactions, just replacing the one atom or other atom by the other group or atom, or one group by the other group or an atom. For example, you can take in nucleophilic substitution reactions whenever we are treating with a base alkaline medium, that X is replaced with OH is replaced with X. Okay, that means alkyl halides are converting into alcohols. Similarly, next, third kind of reactions are elimination reactions. Elimination reactions. What are the elimination reactions? Just removing a group or an atom from the molecule to produce the unsaturated molecules. For example, you take the alkanes. For example, it is having an X here, the hydrogen is here, dehydrohalogenation. Dehydrohalogenation, that X is removed, HX in the form of HX. Then it leads to produce an unsaturated compound. Here the elimination reactions are also several types. We can discuss where it is coming. Next, fourth kind of reaction. Similarly, rearrangement reactions. Rearrangement reactions. What are these rearrangement reactions? Migration of a group or an atom within the molecule from one place to other place. That first initially position is called migration origin. After it is traveling from one position to other position, that is the where it is reached that position is called as migration terminal. For example, you take a group is there H and G. This is the group which is undergoing migration from this is the 1 and 2 position. From first position to second position is moving. Then the such kind of migration is called as rearrangement reactions. In all these cases, if you look into this, all these reactions, three kinds of reactions, an addition reaction, elimination reactions, substitution reactions, and rearrangement. In all these three reactions, you can see that the reaction is proceeds through the formation of a reactive intermediate. Reactive intermediate. What is that reactive intermediate? That any species and a highly activated state may be having a charge or a neutral species, like a positive charged species. If it is a carbon, carbocation. If it is a carbon, it is a carbocation. If it is negative charge, then there is a carbon, carbanion. If it is a neutral one, radical, that is a free radical, carbon free radical. These are known as intermediates. These intermediates, we can isolate it, we can characterize it, we can study their reactivity. Yeah, my voice is audible. Someone is asking something. Can I continue? Right. Then, in all these cases, a reactive intermediate is involved. Now, these reactions are conducted in some solvent phase. Some solvent phase. These reactions are dependent. These reactions are dependent on solvent condition, reagent, catalyst, and a type of intermediate, reactive intermediate generated in the reaction. These are the very common and very formal reactions in the organic chemistry. Except all these reactions, we have another kind of reactions. Another kind of reactions. Those reactions are involving conversion of one molecule to another molecule without involving a reactive intermediate. Are known as pericyclic reactions. These are new class of reactions, much different from the all other reactions. Pericyclic reactions are simple. These reactions are molecular reactions. These reactions are molecular reactions. Very important word we need to remember when you are encounter the word pericyclic reaction. That is these are the molecular reactions. Molecular reactions. How these molecular reactions that takes place? These molecular reactions are involving conversion of some cyclic compound to acyclic compounds, some cyclic compound to unsaturated acyclic compounds, are involving a transition state, not the intermediate. A cyclic array of pi electron transition state is involved in the reaction. Such reactions are known as pericyclic reactions. In this kind of reactions, no intermediate is involved. There is no intermediate involved. Based on the definitions, we can mention some characteristics of pericyclic reactions. What are the characteristics? Characteristics of pericyclic reactions. What are the characteristics of pericyclic reactions? First thing, these are molecular reactions. Molecular reactions. What is the molecular reactions? Involving conversion of one molecule to other molecule without generating any charged species like intermediates. And second one, these reactions are concerted reactions. When the reaction is called as concerted and non-concerted, two words are there: concerted and a non-concerted. The concerted means there is no specific medium or middle compound is generated between the reactant and product. If it is generated anything, we cannot isolate, we cannot characterize it. That is a single step reaction, very fast reaction. Such reactions are known as concerted reactions. What are non-concerted reactions? The reactant initially generates some intermediate. That intermediate can be isolated, can be characterized, can be studied their reactivity, can be studied their stability. Such reactions are known as non-concerted reactions. When we coming to the pericyclic reactions, these are concerted reactions. Concerted reaction means single step reactions. The lifespan of the whatever the activated state is involved in the reaction is very, very negligible, or we cannot find out their formation. Just we imagine that the transition state is generated. That is the hypothetical species is generated in between the reactant and the product. Such reactions are known as concerted reactions. These reactions are proceeds through the formation of a cyclic array of pi electron transition state. Pi electron transition state. What is the pi electron transition state? We can see further. Okay. First, you remember that word, pi electron transition state. These reactions are proceeds through the formation of a cyclic array of pi electron transition state. Pi electron transition state. This pi electron transition state may undergo complete cyclization or may undergo cleavage. If it is undergoing cyclization, a cyclic product is generated. If the cyclic array of transition state may undergo broken or dissociated, that leads to the formation of less number of carbons containing unsaturated compounds. Okay. Next, these reactions are reversible reactions. These reactions are highly reversible reactions. These reactions are reversible reactions. Why these are reversible? We are saying that this reaction is involving cyclic array of transition state. The cyclic array of transition state. This transition state is the excited level, excited, highly energetic state. This highly energetic state may sometimes cross the energy barrier to get the products. Sometimes it may not be cross the energy barrier to produce the product. Whenever it is not able to sufficient energy, having sufficient energy, then it come back to the products. So sorry, come back to the reactants. If it is having sufficient energy, it cross the energy barrier, then it leads to produce the product. Okay. Now this is the reversible reaction. Next, these reactions are induced by thermal, that means heat, thermal or photochemical. Photochemical means light conditions. That means this reaction may be conducted by heating the reaction, right? Or you can irradiate it with this light. Just a second. Next, photochemical conditions and thermal conditions. Next, these reactions are sixth characteristic feature. As we have discussed earlier, previously we have discussed it, the reaction is not involving to form a reactive intermediate. Reaction itself, it is not producing any intermediate. But if it is any intermediate is acting as a starting material, that can give the pericyclic reaction. The reaction itself not participating to produce any reactive intermediate during the formation of reactant to product. Suppose here I am taking product A, reactant A. After irradiation with light or thermal condition, it gives the excited state. This is the cyclic array of transition state. Cyclic array of transition state that leads to produce the product B. This is the transition state. This A is a neutral molecule. After the reaction, a B is the neutral molecule is generated. Suppose the A is a positive charged species. This positive charged species is acting as a reactant. Then it excited. Whenever we are providing that energy. Finally, it leads to produce a product B that may be having a radical, that may be a positive charge, that may be a negative charge. That means what you understand from this, the pericyclic reaction itself not producing any reactive intermediate, but any reactive intermediate can involve in the reaction to produce the pericyclic reaction. That you need to remember. Next characteristic feature is, yeah, you already know, no intermediate is involved. No intermediate is involved. But intermediate can participate in the pericyclic reaction. Can participate in the pericyclic reaction. Next, seven characteristic feature. These reactions are not influenced by not affected by first one, solvent cannot be affect the reaction. Next, reagent, any reagent if we are adding to the reaction, that will not affect the progress of the reaction. Catalyst cannot influence the reaction. These are the simple characteristic features of pericyclic reaction. The last but one, these are highly stereospecific. Highly stereospecific. Highly stereospecific means what? If you understand the stereochemistry, you can easily identify that word. Stereospecific, stereoselective. Look at here. Suppose some A and B are involved in the reaction, or otherwise you take the only one. A is involved in the reaction. If it is involved particular reaction, after reaction it can produce only B. Or another case, after the reaction it can produce or undergoing any some dissociation or association, whatever it may be, it leads to produce B plus C. Now such kind, here in this kind only one product is the major product. Such reactions are known as stereospecific reaction. Only specific product is generated in the reaction. That is known as stereospecific reaction. In this case, there is a selectivity. That means it may either produce B or C. Two unequal portions of the products are generated. Suppose it may generate B is the 60% and the C is the 40%. Or in some cases, if the reaction condition is changed, it may be 60%, it may be 40%. Or after some times you are applying any other condition, it may leads to produce 50% and 50%. These kind of reactions are known as stereoselective reactions. Stereoselective but when it is stereo, when it is regio, other word is stereoselective and regioselective. Stereoselective and regioselective. This stereo means when the reactions are involving stereoisomers. When the reaction is involving stereoisomers, is the particular stereochemistry is involved, the three-dimensional study is required. Such reactions are mentioned with this stereo word. That stereo word, stereospecific or stereoselective. When it is called is regio, that molecule is not belongs to any stereochemistry. That means that it will not showing any diastereomerism, it will not showing any stereoisomerism, it will not showing any enantiomerism. In such condition, that reaction is producing, A is producing only B as the product. That is called regioselective. Sorry, regiospecific. It is involving two products formation, that is involving formation of two products, that is called regioselective, where the stereochemistry is not playing a crucial role here. Such reactions are known as regioselective, regiospecific. Stereochemistry is playing crucial role. Such reactions are mentioned with the stereoselective and stereospecific. Therefore, here the pericyclic reactions are highly stereospecific. That means it is involving only one specific stereoisomers in the reaction. Right. Then here also we can mention it. How we can decide the stereospecificity? That means that the pericyclic reaction involved, can be allowed under thermal condition. That means the reaction can only proceed through the thermal condition that give one particular stereoisomer, which is different from the same chemical reaction is undergone under photochemical condition that will produce another kind of stereoisomer. That means the stereoisomers produced under thermal condition and under photochemical conditions, both are different. Based on such reason, we can call it as this reaction is stereospecific. Under thermal condition is produced one particular product that is different from the product which is produced under photochemical condition. Okay, these are the general characteristic features of pericyclic reaction. In your exam and short answer question, write the characteristics of pericyclic reactions. First, define the pericyclic reaction and write the characteristic features of pericyclic reaction. This is the answer for the short answer question. It may appear in the examination, theory examination. Okay. Now coming to classification of pericyclic reactions. Classification of pericyclic reactions. Am I audible? Are you following?
Yes, sir.
Right. Now, based on the reactions involved in the pericyclic reactions, sometimes it may be cyclizations, sometimes maybe it is combining two molecules to produce another new molecule, and sometimes the migration of one group or atom from one portion of the molecule to the other portion. Right. Based on these paths, pericyclic reactions are classified into three types. The first one is electrocyclization reactions. Electrocyclization reactions. Some people, this is also called as electrocyclic reactions. Electrocyclic reactions. The second one, cycloaddition reactions. Cycloaddition reactions. And the third one, sigmatropic rearrangement reactions. Sigmatropic rearrangement reactions. Based on the mechanism and pathway, the pericyclic reactions are classified into three types. One is electrocyclic reactions or electrocyclization reactions. And the second one is the cycloaddition reactions. And the third one is the sigmatropic reactions or sigmatropic rearrangement reactions. We can call it as the sigmatropic rearrangement reactions or sigmatropic reactions. Sigmatropic reactions. Now coming to the first one, electrocyclic reactions or electrocyclization reactions. Electrocyclic reactions. What are electrocyclic reactions? Now, we are already known the pericyclic reactions are reversible reactions. Right. If you take any unsaturated molecule which is undergo the cyclization by combining the terminal carbons of polyene system to produce a cyclic compound from acyclic unsaturated compounds. How it is defined? An electrocyclic reaction can be defined formation of a sigma bond between the terminal conjugated pi system or reverse. Here, first I am taking one example, later we will discuss the definition. Suppose you take, this is the one, two, three, 4. 1, 3 butadiene, right? For our understanding, I am writing it as cis form. This is also 1, 3 butadiene. This 1, 3 butadiene is substituted with different groups. Already attached with 2 hydrogens. The hydrogens, you to take it as hydrogens. This is the 1, 3 butadiene. In place of hydrogens, you can replace with other groups like methyl group, ethyl group, whatever it may be, you can replace it. Okay. Now I am here taking the as it is that example, which is an irradiation or heating. That means we are providing energy by thermal condition, by heating it, or we are irradiated by the light. Now the two terminus, these are the terminal carbons. This is the one terminal and is the second terminal. This is the terminus 1, terminus 2. These two carbons are forming a bond by using these 5 electrons. By using these 5 electrons. By using these 5 electrons, it can produce the sigma bond between the two terminal carbons. How it is arranged? These 5 bonds, 5 bonds are consumed to produce the sigma bond between the C1 and C4. Now, this second carbon and third carbon is having 1 electron, 5 electrons are there. Those 5 electrons are combined to produce a 5 bond here. Right. Now, this is the cyclobutene. Cyclobutene is the product. Now, when you see the forward reaction is the combining of two terminal carbon to form a bond, sigma bond between by consuming 2 5 bonds to generate a new sigma bond and a new 5 bond is the cyclization reaction. This reaction is known as cyclization reaction, the forward reaction in which the 4 5 electrons, here the 2 5 electrons are here, from this 5 bond 2 5 electrons, from this bond 2 5 electrons, total 4 5 electrons. 4 5 electrons are consumed in the reaction to produce a sigma bond and a new 5 bond. That means 2 5 electrons and 2 sigma electrons are generated, converted. Such reaction, the forward reaction, is known as electrocyclic ring closure reaction. Electrocyclic ring closure reaction. Electrocyclic ring closure reaction. When you come into the backward reaction, that means here in the backward reaction, the cyclobutene is the starting material. Cyclobutene is the starting material. Now, whenever you are conducting this reverse reaction, that means you are starting the pericyclic reaction with the cyclobutene to convert it into 1, 3 butadiene. Now, this reaction, the reverse reaction which is involving consuming of 2 sigma electrons and 2 pi electrons to generate the 4 pi electrons. Newly produced 4 pi electrons. Acyclic system is generated. Such observation is known as electrocyclic ring opening reaction. Electrocyclic ring opening reaction. The forward reaction is electrocyclic ring closure reaction. The backward reaction is electrocyclic ring opening reaction. Okay. Now this is the electrocyclic reactions. What is the electrocyclic reaction? Electrocyclic reaction is formation of a sigma bond. Formation of a sigma bond between the 2 terminal carbons of a cyclic system to produce a unsaturated cyclic system, or reverse, a unsaturated cyclic system is undergoing dissociation to produce an acyclic polyunsaturated compound by the consumption of some pi electrons and some sigma electrons to produce the unsaturated system. Okay, if you simplify it, an electrocyclic reaction is a formation of sigma bond between the terminal conjugated pi system, or a reverse process is known as electrocyclic reaction. Single statement lo మీరు define చేయాలంటే simple. Single statement lo define చేయాలంటే formation of a sigma bond. Simple statement of definition. Formation of sigma bond between the terminal carbons to produce cyclic product, or reverse, is known as electrocyclic reactions. Electrocyclic reactions. Okay. Now, further electrocyclic reactions are classified based on the number of electrons involved in it. Based on the number of electrons involved in it. Further, the electrocyclic reactions are classified into 2 types. Electrocyclic reactions are further classified into 2 types. One is 4n pi electrons, or sometimes it is shown with 4n electrons involved electrocyclic reactions. Electrocyclic reactions. The second one is 4n5 plus 2 electrons. 4n5 plus 2 electrons involved electrocyclic reactions. For those examples, previous one is the whatever you have taken 1,3-butadiene derivatives, it is irradiated under light or supplying heat, backward or forward. You can get the simple (1,3) butadiene, How many number of electrons? The 2 5 electrons from here, 2 5 electrons from the second 5. Total 4 5 electrons are involved. Now, in the forward reaction, 4 5 electrons are participating in the reaction. In the backward, 2 sigma electrons by the cleavage of the sigma bond and the cleavage of this 5 bond. 2 5 electrons. Therefore, these are known as 4n electrons. 4n electrons or 4 electrons are 2 sigma electrons plus 2 5 electrons are involved in the reaction. This is known as 4n 5 electrons involved electrocyclic reactions. Electrocyclic reactions. Next, second one example. If you take the same kind of molecule, that is number 1, 2, 3, 4, 5, 6. 1, 3, 5. Hexatriene. This is the hexatriene, which is an irradiation by the light or heating with the heat, supplying the heat. Now it is undergoing cyclization by the terminal carbons, that C1 and C6 form a sigma bond. A cyclic 6-membered ring is generated by the consumption of 3 5 bonds. That means 6 5 electrons are consumed to produce one sigma bond and 2 new 5 bonds. 2 new 5 bonds. This is the newly formed 5 bond, newly formed 5 bond, and newly formed sigma bond. Here the 3 5 bonds are consumed for the formation of the cyclic product. How many electrons are involved here? 2 plus 2 plus 2. Total 6 5 electrons are involved in this reaction. This can be written like this: 4n 5 plus 2 electrons. 4n, where n is equal to 3. N is equal to 3. Sorry, where n is equal to 1. Where n is equal to 1. 4 into 1 plus 2. That is 6 5 electrons. Total 6 5 electrons. Here the 2 plus 2. 2 plus 2 plus 6. 2 sigma electrons. Total here also 6n electrons, we call it as. Therefore, this electrocyclic reaction is known as 4n5 plus 2 electrons. These 2 electrons may be sigma electrons or 5 electrons. In the reverse case, it is the sigma electrons. In the forward case, it is the 5 electrons involved electrocyclic reactions. Electrocyclic reaction. Okay, this is about the electrocyclic reactions. Some other examples are there. You can open your book. You can practice those. Some other examples. Okay. Next class of pericyclic reaction is cycloaddition reaction. Cycloaddition reaction. Cycloaddition reaction. Right. What is the addition? Suppose you see that. What is the addition in the normal case addition reactions? Electrophilic additions, nucleophilic additions. Simply combining the 2 molecules or 3 molecules, you will get the final adduct. That is the addition reaction. Here also same case. You can take any 2 unsaturated molecules, undergoes conjugate addition to produce a conjugate adduct. Or reverse, the conjugate adduct may be dissociated to produce 2 or more unsaturated species. Unsaturated compounds are known as cycloaddition reactions. For example, here I am taking 2 olefins or ethylenes. These are the 2 ethylene molecules. You can consider these are the 2 5 compounds. Because it is having a 5 bond, that is the reason it is having 2 5 electrons. The 5 bond is there. It is also having 2 5 electrons. Okay, this is considered as a 1,5 system, or it is called as a first 5 system. This is considered as a second 5 system. 2 conjugated 5 systems are 2 5 systems are undergoing conjugate addition in the condition of thermal or photochemical condition to produce a cyclic adduct. Produce a cyclic adduct. This is an adduct. Adduct, how it is adduct? Both the molecules are combined together, produces a single compound. That single compound is known as adduct. That is cyclic adduct. This cyclic adduct formation is known as cycloaddition reaction. Okay. Here, we know that pericyclic reactions are reversible. The addition is taking place between the 2 5 systems. That is known as cycloaddition reaction. Cycloaddition reactions. That means the forward reaction. The 2 sigma bonds are formed. Look at here. These 5 electrons may be here. You are imagine it. These 5 electrons are moving here. Produces 2 sigma bonds. 2 sigma bonds are formed by the consumption of 2 5 bonds. By the consumption of 2 5 bonds to produce a cyclic adduct is known as cycloaddition. The forward reaction is cycloaddition. Now coming to the backward reaction. By the consuming of 2 sigma bonds, suppose the sigma bond electrons are moving here, the sigma bond electrons are moving here. That leads to dissociated to 2 molecules is known as cycloreversion reaction. The reverse reaction is known as cycloreversion reaction. The cycloreversion reaction. Cycloreversion reaction. Right. The forward reaction is cycloaddition reaction. The backward reaction is cycloreversion reaction. Okay. Next. Again, these reactions are classified into 2 types based on the number of electrons involved in the reaction. Based on the number of electrons involved in the reaction, it is classified into 2 types. One is 2 plus 2 cycloadditions. Actually, these cycloadditions are denoted with the M plus N cycloadditions. In general, cycloadditions. Suppose the 2 5 systems are participating in the reaction. 2 5 systems are participating in the reaction. The first 5 system is having M number of 5 electrons, that is the M. If it is second 5 system is having N number of electrons, that is the N. M plus N cycloaddition. Suppose sometimes the 3 or more number of 5 systems are participating in the reaction. Suppose the 5 systems are participating in the reaction, that is indicated with the M plus N with some other K, whatever. That is the sequence is increasing, enhance. We are adding always one other numerical value. The number of 5 systems are increasing. Here only we consider it as 2 5 systems or 2 5 molecules are participating in the addition reaction. That is indicated with the M plus N cycloaddition reaction. Here the M is equal to 2 electrons, where N is equal to 2 electrons. The first class is 2 plus 2 cycloaddition. or also it can be classified like that. Phi 2, the phi system with 2 electrons, the phi system with 2 electrons. It is in square brackets. Phi plus phi 2 plus phi 2, it is a normal script, it is a superscript, it is a normal script, it is a super normal script, it is a superscript. Phi 2 plus phi 2 cycloaddition. When it is mentioned with 4n pi electrons or 4n electrons are involved in the total reaction, we denote it with this way, phi 2 plus phi 2 cycloaddition. Right. Next, second type of reaction. 4 plus 2 cycloaddition or phi 4 plus phi 2 cycloaddition. For the first example, I have already seen that a olefin system with the 2 phi systems with 2 phi electrons. This is the phi system with 2 phi electrons. This is the phi system with 2 phi electrons. Now it leads to produces a cyclic adduct. This is known as 2 plus 2 cycloaddition or phi 2 plus phi 2 cycloaddition. Right. Suppose if a phi system with the number of electrons are 4 electrons, it is involving with 4 phi electrons, and a second phi system with 2 phi electrons. Then under thermal or photochemical condition, it produces a cyclic adduct. By the consumption of 3 phi bonds, it leads to formation of 2 sigma bonds and 1 pi bond. Then this reaction is known as 4 plus 2 cycloaddition. 4 plus 2 cycloaddition, or we can represent like this, phi 4 plus phi 2 cycloaddition. Phi 4 plus phi 2 cycloaddition. Right. These are the general reactions for the cycloaddition reactions. Now coming to the sigmatropic reactions. The third class of reactions are sigmatropic reactions. We have several examples for cycloaddition in your book. You can practice. Next, sigmatropic reactions. What are the sigmatropic reactions? These sigmatropic reactions are also called rearrangement reactions. Sigmatropic rearrangement reactions. Why it is rearrangement? The definition itself indicates that rearrangement. That means migration of a group or an atom from its origin to migration origin to migration terminal. Migration terminal to produce new molecule is known as sigmatropic rearrangement reaction. Look at it. Here I am going to give you a generalized example. Suppose this is the phi system. You can take some allylic system here. A simple allylic system is substituted with deuterium here. Suppose right. Suppose it is here this end is substituted with some R group, that may be methyl group. Here it is methyl group. Suppose it is hydrogen here, and the same hydrogen is here. Here it is substituted with some ethyl group here, for example. Right. Whenever you are irradiated with light or under thermal condition, this group or an atom, the deuterium is undergoing migration from its. Now I mention it 1, 2, 3. Or you can also, with respect to the migration, this count is different from the iodine. Okay, because this sigma bond is the reference bond. The sigma bond is reference bond. Now this sigma bond is labeled with both the ends with 1 and 1. Both the ends with the 1 and 1. Please remember that. It is not possible to repeat again and again during all over the block. Okay, you remember it. Whenever you are whenever you are studying the sigmatropic rearrangement reactions, you need to recognize where the migration is initiated. That is known as this migration origin. This migration origin sigma bond is labeled with 1 and 1, both the sides. In this deuterium is the only one atom. There is no need to continue the numbering because there is no other atoms or groups are attached to the deuterium. But in this case, this is the pi system. Across the other carbons or atoms are attached to each other. Now continue the numbering in this unsaturated system. This is 2, this is the 3. Now for the migration, this sigma bond is homolytically cleaved. Homolytically cleaved means equally cleaved. The sigma bonded electrons are equally taken, withdrawn, right? During the migration, it can generate a transition state. That is the deuterium. This is the deuterium. Maybe s orbital. It is partially attached with the migration origin. It is partially attached with the migration origin. Also partially attached with the where it is going to be reached. There is the migration terminal. This is going to be here. Now this is the cyclic array of transition state. This is known as cyclic array of transition state. This transition state is known as cyclic array of transition state. Its lifetime is very lifespan is very little. Okay, we cannot recognize it for the formation of this transition state. After complete migration, the deuterium is reaching here. The CH is here. Hydrogen is here. This is the ethyl group and hydrogen is here. Look at here. This is the migration origin where the initially deuterium is located. This is known as migration origin. I'm going to write the full name. Migration origin. After complete migration of this deuterium, where it is destinated to this position. This is known as migration terminus. Migration terminus. We can call it, we can represent it MT. MT. This is represented with the MO. Okay. This shift is known as sigmatropic shift. This shift is known as sigmatropic shift. What kind of shift it is? That you need to classify this migration or this shift or this sigmatropic shift based on the number of positions or the distance which is going to be traveled. That will be counted based on the numbering what we have given to the phi system. It is the 1 deuterium. from first position to it is reaching to third position. 1, 2, 3. Generally, it is represented with I. In general condition, it is J. Now, in general, it is called as I comma J shift. I comma J sigma tropic shift. Now, what is the I here? I is 1. What is the J here? 3. Now the sigma tropic shift is 1 comma 3 sigma tropic shift comma 3 sigma tropic shift. Based on the position of the migration termini and migration origin, we can classify the sigma tropic reaction in several ways. That is 1 comma 3 shift, 3 comma 3 shift, or 1 comma 5 shift, and 1 comma 7 shift. Like that, we can classify in several ways based on the reaction, based on the reaction which is involving from the shift migration origin to migration terminal, and the numbering of that 5 system, the number of carbons which are involved in that migration. That is known as 1 comma 3 shift, when the group is shifting from first position to the third position, or a 3-3 shift. Here, this is the exceptional one. You can see that. For example, cyclohexatriene. Generally, it is seen in Claisen rearrangements or Cope rearrangement reactions. Just right. You can see that. I'm written in non-planar form. Actually, this is whenever we are considering it in the planar form. I'm sorry, my throat is not supporting. It just recovered from the fever today. Right. This is planar form. This is the non-planar form. Right. Now, it is involving, this is the 1 and 1. Both the sides of the sigma bond labeled with 1 and 1, and continue the remaining part. 2, 3, 2, 3. Right. After migration, you can mention it with the star. Okay. Then it is generated a sigma bond between these two. That is 1, 2, 3. 1, 2, 3. The I value of the first 5 system is I value, this one. And J value is also 3. Now, that means here in this case also, you recognize it. Where the initial migrating group numbering, this is the D. D is 1 position. The same D is attached at 3rd position. But here, the 1 and 1 are both attached at initially, but at the final product formation, the third position of the 1,5 system is attached to the 3rd position of the other 5 system. Therefore, suppose this is considered as the migrating group. The migrating group, which is associated to the migration termini, is the 3rd carbon. Therefore, I is equal to 3. And this is the 5 system, original core 5 system. In that core system, which is associated with the migrating group, that position is 3. Therefore, the J is also 3. Now, the IJ shift is 3, 3 shift. Difference what is the I will show the difference also. You can see that. You can use the same example. We get 1, 1, 2, 3, 2, 3. Right? Whenever you are irradiating, it forms a transition state like this. Right? Is the 1, 1, 2, 2, 3. Right? For our understanding, it is labeled with the isotopic carbon. Right? After migration, what we have seen that the product is like that, but the star one is at the 1, 5 end, and the star one is here. Initially, the star one is here. Therefore, 1, 2, 3. This is the 1, 2, 3. Now the shift is, if you treat this one is the migration group, migrating group. If you treat this part is the migration or phi system. It is treated as phi system. It is treated as migrating group. Right? It is treated as migrating group. Right? Now the where the I is equal to taken from the migrating group. That is the 1. The J is taken from the phi system where it is attached 3. Now this shift is called as 1, 3 shift. This shift is known as 1, 3 shift. Okay, these are the different kinds of pericyclic reactions. Now before ending the class, I am just recollecting what we have discussing in the entire session. The pericyclic reactions are chemical reactions which are involving conversion of one molecule to other molecule, which through the formation of cyclic 5-electron transition state. These pericyclic reactions are highly stereospecific, not influenced by the solvent, reagent, catalyst, and no intermediates are generated during the reaction. These reactions are induced by the photochemical conditions and thermal conditions. These are highly molecular molecular reaction. These are the characteristic features of pericyclic reactions. Now, when we come into the classification of pericyclic reactions are classified into 3 types. One is electrocyclic reaction, second one is the cycloaddition reaction, and the third one is the sigmatropic rearrangement reactions. Electrocyclic reactions are the cyclization of the acyclic system by forming the sigma bond between the terminal carbons or reverse are known as electrocyclic reactions. Cycloaddition reaction is what? A conjugate addition of 1 or 2 phi systems to produce the cyclic adduct or reverse are known as cycloaddition reactions. The sigmatropic reaction is what? The third class is sigmatropic rearrangement reactions or sigmatropic shift reactions are simply called it as sigmatropic reactions. The sigmatropic reactions are involving the migration of a group and an atom from one position of the other position of the phi system by traveling across the phi system to produce the new class of product is known as sigmatropic rearrangement reaction. Do you have any doubts up to this?
No, sir.
Any other? Okay. Tomorrow in the tomorrow class, I am going to start the stereochemistry of pericyclic reactions. Can I continue? Next class, when it is the next class, I will take it. If we have the time, we'll just start the next topic. I think next class is the Keshav sir class. If you have any doubts, now you can interact with me. We have 4 minutes more time. Yeah, next class is 2 o'clock. Lunch break is given.
Okay, sir.
Okay. Do you have any doubts? I will share this OneNote. Okay. You can open it. You can make it PDF. Take a print and practice.
Okay, please share. Share.
Yeah. Yeah. Okay. After tomorrow class, I will say.
Okay, sir. Okay.
Tomorrow class, entire notes will be sent to you. Okay.
Okay, sir.
Okay,
Okay.
thank you, sir.
Right. Thank you.
Thank you, sir.